Hello to Ladies in Tech. My topic is going to be on series circuit. In front of you, I have a simple series circuit. We have 3 resistors hooked up in series and connected to a 12-volt battery. You can tell that it's a series circuit because we only have one way for the current to flow through this whole circuit. So you can see off of the power supply here, off the battery, we know it's the positive side of the battery because it has a longer bar here. The current's going to flow up and around, up into R1, through R1, which is 200 ohms, and then into R3, which is 100 ohms. And then the last one it's going to flow through is R2, which is 430 ohms, and back to our negative on our battery. So our current flow is like this. There's no other path. You have to go through one resistor in order to get through the other one. We have a complete series circuit. So what we're going to do with this circuit, we're going to solve for some unknowns at this point. And what we're going to solve for is our R total, which I'm going to call RT. We're going to solve for current. And we're also going to solve for voltage drops at each of the resistors. So there's some things that we need to keep in mind when we go to start solving for this circuit. The one thing that we didn't need to think about, or we know as a rule, is the fact that in a series circuit, current is always the same, no matter where you measure it. So if you measure the current here at the battery, it should be the same as the current over here, or over here, or over here. So that tells me that the current at R1 is going to be the same as the current at R3, going to be the same as the current of R2. So we need to keep that in mind. Also too, there's a couple formulas that we're going to be using, and I'll discuss those, but we just want to make sure we're following our Ohm's Law. So our biggest one we're going to use here today is V equals I times R. And we're going to use it in all different forms. So that's the only formula that we're going to use here today in order to solve this problem. Oh, actually, our sum of our resistors too will also be the formula that we're using. So let's get started. So that's the first thing we're going to solve for is our R total. So our R total is going to equal our R1 plus our R2 plus our R3. So put it simply, add up all the resistors in the circuit and you'll have your total current, or your total resistance, sorry. RT equals 200 ohms plus 430 ohms plus 100 ohms. So our R total for this circuit is 730 ohms. So now the next thing I'm going to solve for, since now I know my R total, I'm going to solve for my current for this circuit. So to solve for our current, we're going to use Ohm's Law, which is I equals V over R. So V being our voltage and R being our total resistance. So I is going to equal 12 over V divided by 730 ohms. So our I for this circuit is 0.0164 amps. Reminder that current is measured in amps. So now let's solve for, since we know the current now, and we know that current is the same at any point in the circuit, let's solve for our voltage drops at each of the resistors. Let's start by solving V1. So I'm calling V1, which is the voltage drop at resistor 1, is simply I1 times R1. So here we are using another variation of V equals I times R. So V is going to equal 0.0164 amps times 200 ohms. So the voltage drop at V1 is going to equal 3.28 volts. Now let's solve for V2. So we're solving for V2. V2 is going to equal I2 times R2. We have to remember that I2 is going to be the same value as I1. So V2 is going to equal 0.0164 amps times 430 ohms. So the voltage drop at V2 is going to equal 7.052 volts. And finally, let's solve for V3, which is I3 times R3. which is 0.0164 amps, times 100 ohms, which gives us a voltage drop at V3 as 1.64 volts. So that there sums up finding the voltage drops at each of the resistors. One way you can check yourself for the voltage drop is that each of the voltage drops themselves, so V1, V2, V3, the sum of them, so if you add them all together, should equal the total voltage of 12 volts. So we're pretty darn close with equal the 12 volts shown there. So if you have any comments or questions, please post them below, and thanks for spending your time with me. Bye now.